Eureka! The story so far. Force depends both upon the mass a thing has and upon how much acceleration you want to give it. Since acceleration refers to rate of change of speed, and since speed can be measured in meters per second, acceleration is measured in meters per second per second. And now, gravity. If you sit under an apple tree for long enough, this is what is bound to happen. Which is very odd when you come to think of it, since we know that things like to keep on doing what they're already doing because of inertia, because they're lazy. So why did the apple fall down? Aren't apples lazy? This is the problem that puzzled Sir Isaac Newton nearly 300 years ago. The apple was hanging perfectly happily by its stem from a branch of the apple tree. But there comes a time in the life of every apple when it's grown to such a size and such a mass that its stem can no longer exert enough force to hold it up. And hang on a minute, this looks like a tug-of-war. The stem is pulling the apple up, while another force is trying to pull the apple down. What other force? Well, it must be the force of gravity. That's why things fall down, isn't it? Because gravity pulls them down. Yes, but why? What is gravity? Why does it pull things down? That's the question that had Newton guessing until he saw the apple fall and suddenly realized that all objects in the universe attract all other objects to some extent, but to such a small extent that we don't usually notice any movement. But the more mass objects have, the more they attract each other. Yes, we know that the apple hasn't got much mass, but the Earth has. Such a huge amount of mass, in fact, that its gravitational force is enough to attract every single thing that comes anywhere near it, from apples to acrobats, and from oil paintings to green bottles hanging on the wall. Once the force of gravity exerted by the Earth exceeds the force that is holding the object up, down it comes. But just how strong is gravity? Exactly how much force was there trying to pull the apple down from the tree? Well, let's work it out. We know that force equals mass times acceleration. So the force of gravity must equal the mass of the apple, say 100 grams, times the acceleration of the apple. But do falling apples accelerate? Do they go faster and faster the longer they fall? Try sitting under a very tall apple tree, and you'll soon find out. In fact, scientists have calculated that the rate of acceleration at which every object falls to the Earth is roughly 10 meters per second per second. This applies to everything: acrobats, oil paintings, green bottles, and apples, of course. So we can now finish our calculation. The force of gravity pulling the apple down is 100 grams times 10 meters per second per second. And if you want to stop the apple falling, your hand must balance this exactly by pushing the apple up with an equal force. Amazing how complicated a simple little thing like holding an apple in your hand can be, isn't it? Let's simplify it. In honor of the man holding the apple, let's call a force that accelerates 100 grams at 10 meters per second 1 Newton. So that everyone will know that the force of gravity acting on the average apple is exactly 1 Newton. Conversely, that the force needed to hold up the average apple is also exactly 1 Newton. This makes life simpler, and it also shows you that 1 Newton really isn't very much.